Good morning.
Good morning.
Good morning.
Yeah, it is.
Morning.
Nikki won't be here today.
Hi.
Okay. Janet told me that she was not available either. Well, that may be all of us then.
Well, for once you see my face.
Yeah, we have Helen dropping in.
I have followed everything on the videos.
That was definitely a wonderful idea.
They're very good. They're very good because you can repeat them.
Mhm.
And I really like that very much. It's a very good thing to do. I
So
told
yeah.
my family to do, to listen.
Okay. Well, might as well get going then. Um, the so the topic this week is really, I guess, is sort of properly theological. Um, and what I want to try to leave you with is a sense that that the role that mystery plays in religion can be played by sort of reality itself. The as the reality that we uncover in our day-to-day lives is actually mysterious enough that it's still checking all those kind of boxes that religion's looking for. Um, and it might seem sort of a little different to suggest this kind of language, but the end result of that would be something that that even that the approach I'm recommending would allow for a kind of mysticism, but it's obviously not a mysticism that's attached to a divine. It would be a mysticism attached to mundane reality. It's just the mundane reality that we know from modern physics, which is just really weird. So it's the fact that the world that we're uncovering is so sort of fundamentally bizarre that I think it naturally kind of opens up that kind of space. So I think to unpack that, sort of a few different kind of things going on in there, but one, and I don't, I didn't, it didn't, this didn't come up in the book. I came up with this idea a little later, but one is to think about the concept of spirituality. So, um, spirituality is a curious sort of thing in the study of religion. The word has a very long history attached to the Catholic Church, and so for centuries, what the word spirituality meant was the practices of uh, ideally sort of the saints, but then those practices could be sort of adopted by other people, sort of by monks and nuns who are seeking to emulate the saints. And so you have these spiritual practices. So the spirituality is the spiritual practice. And when we get to kind of, well, the modern period, sort of broadly speaking, at least certainly 1600s and forward. Oh my God, cats suddenly flinging water everywhere. When we get there, there's this turn that philosophy makes following the work of Descartes to move kind of away from a heavy emphasis on metaphysics, which was very popular in the Middle Ages, to epistemology. So less random, well, less wild speculation about the nature of reality, the metaphysics, more interest on what is it we can know. So that's epistemology. And when you make that turn, one kind of thing that becomes more, I think, more obvious to the culture to explore is the nature of experience itself. So if our knowledge is fundamentally then about experiences, well, then that means at some point you want to start noticing that. Well, what does that mean? So we find, especially when we get, into what we think of modernity, more 19th century going forward, that conversations about spirituality have kind of tracked that change in emphasis, and have been tracking experience more and more and more. And so people have in our world, right, radically generalized from this idea of spirituality. And so now people talk about spirituality as a universal sort of phenomenon, in some sense, that anyone can have a spiritual life. But the question, sort of lingering in the background of all of that is, what the heck are these people talking about? What do they really mean by that kind of language? And in the study of religion, because everything the academy is very good at siloing things, right? If you study chemistry, you go to a chemistry department. Well, even in religion, there's a lot of that siloing going on. So if you study Christianity, then you study Christianity. And if you study Hinduism, you study Hinduism. And so those scholars weren't necessarily talking a whole lot, but each of them is their traditions are all along the way developing this kind of language, talking about spirituality and talking about religious practices and religious experience and all of that. So we get to a point where it's worth asking the general question, well, can we come up with proper generic definitions of these terms? And curiously enough, it's not something that's gotten a lot of attention. So I wrote an essay a couple of years ago, and for a book on Eric Fromm, and I've introduced you to him a little bit. Fromm talks a lot about love, mutually supportive relationships thing. Yes, somebody does have some background noise going on. I'm not sure where that's coming from.
I think it might be Bill. Can you mute Bill?
Yeah, but
okay. So at any rate, I was, sort of thinking about this, and thinking about Fromm, and something occurred to me that if we try, it's still there, isn't it? If we really try to generalize on this concept, that what we get from spirituality is that that humans want connections. And so I think what I was describing in that chapter was, we could think about spirituality as being a kind of experience that is like love, but is not reciprocal in the way we normally think of love. Now, here, of course, I want to acknowledge that religious people have talked about love for a long time, and talked about love as an experience of divine love and that kind of thing. And what I want to notice there is that language is strained. We understand it in context because the analogies with love are clear to us. But I think the language is strained because the divine is not something one can properly have a reciprocal loving relationship with. Just as nature is not something one can have a properly reciprocal loving relationship with. You may feel that nature loves you, but you can try to love nature, but this is not the same thing. This is not nature is much bigger, and in fact, it may at some point smite you. So I think what spirituality is a feeling of connection, which often takes a form of familiarity. So it can be a feeling of reconnection with something that's bigger than ourself. And so that could be something that is divine, could be something that's nature, could be something that's even social. So I think about people having religious experiences at the symphony. So you're having this experience it's something bigger than you, but you feel connected to it or reconnected to it. And I think that's the feeling that spirituality is picking out, that the word spirituality is picking out generally. So I think, I mean, what I want to notice in that is that definitionally, I was trying to come up with something like sort of in the main part of the book, I'm trying to come up with definitions that work regardless of the content that's being plugged in. So the content could be theistic or not, but so that doesn't matter. The content is sort of irrelevant to the theory needs to be general enough to accommodate, that's the word, accommodate any content that someone would plug in that is kind of identifiably religious in terms of the theory of religion. So same here with spirituality, that any kind of experience people have that they would normally use that word, the theory needs to kind of account for it in order to be a good generic theory. And I think this one works that way. But what I want you to notice, though, is that when we're making this atheist turn, is that you can still make that atheist turn, and with this definition of spirituality, that it makes perfect sense for me, under this definition, to talk about people having experiences that they would call spirituality, their spirituality, because we're talking about a feeling of connection. And in fact, when I'm laying out the atheist version of this kind of thinking, what I would go on to say is that what people normally call God, I would say, is the name of the feeling. And that the philosophical confusion is in thinking that what you've picked out with the name is a cause of the feeling. So what I'm saying is God's not the name of the cause of the feeling, God's the name of the feeling. So people have those experiences, they put these labels on them, and I'm going to say, that's, I think, what they're picking out. Well, all right. But what that gets from theological perspective that I'm going after is that, okay, so it's not a God that's causing the experience, it's something else that's causing the experience, which means people are still having these really interesting and bizarre experiences. And they're often compelling, if not transformative. Well, they're usually compelling, sometimes transformative. But reality itself must be weird enough that it's doing those things too, and thus mystery. So I can comfortably take out, I can carefully preserve that piece of mystery, which seems to be an important part of the aesthetics of religion, without having to rely on a divine as an answer to why that mystery would still be in place. I can use something that's actually, in a sense, even more bizarre. And here, let me sort of share something a little more bizarre with you. Because what we have are these people telling us, there we go. There we go. All right, so let me do the science version of this first, and then come back to the how dialectics as a philosophy applies to this. So the first thing I want to introduce you to is there is fundamental weirdness in the world that comes in two directions. I think two primary directions for us non-experts. One is from mathematics, and I'll introduce you to Benoit Mandelbrot here, and the other will come from physics, and there we'll introduce you to string theory and supersymmetry. So this is the man, Benoit Mandelbrot, who came up with the Mandelbrot set and invented fractal geometry. So we'll try and explain what that is along the way here, but this video is not so much to the lesson as it is just, here's the man, and I thought it'd be nice for you to hear a little from him personally. And
Richard, did he invent it or discover it?
Well, there you go. Right. It's as a pattern in the world, it's discovered. As a mathematical trick, it's invented. Maybe is a way to think about it. We have to come up with the tool to figure it, to find it. Yeah.
Very old. Roughness is part of human life forever and forever. And ancient authors have written about it. it was very much uncontrollable. And in a certain sense, it seemed to be the extreme of complexity, just a mess, and a mess. There are many different kinds of mess. Now, in fact, by complete fluke, I got involved many years ago in the study of this form of complexity. And to my utter amazement, I found traces, very strong traces, I must say, of order in that roughness. And so today I would like to present to you a few examples of what this represents. I prefer the word roughness to the word irregularity, because irregularity, to somebody who had Latin in my long past use, means the contrary of regularity. But it is not so. Regularity is a contrary of roughness, because the basic aspect of the world is very rough.
Okay, so I just he's a charming man, and I think it's nice. It's fun listening to him. He has a wonderful voice. But here is actually the short video to really explain the idea. And what I think the thing to keep in mind is that as a matter of kind of mystical sort of speculation, what people are really after is patterns in the world, patterns in their experience. And so that's sort of that fundamental issue is gonna be here all along. What is the world offering us in terms of complexity of patterns that people can be seeking out and trying to explore?
Chaos, present in everything from a drop of water to the galaxies in our universe, has long fascinated people from cultures around the world. The natural disorder present in the branches of trees, lightning, and coastlines, to name a few examples, may seem to be completely chaotic. However, self-similarity within these phenomena is much more organized than it appears. Repeating patterns in many natural objects and processes are known as fractals, figures that show self-similarity at different levels. The study of fractals, both in nature and pure mathematics, has advanced numerous branches of science, such as computing, telecommunications, fluid dynamics, biology, and medicine, and can offer innovative new perspectives on human science and technology. Almost everything in the universe is constantly changing, and while fractals have been described as patterns of chaos, they can also be described as patterns of change in the context of natural fractals. In many cases, fractal patterns are the most efficient way to deliver nutrients, harvest sunlight, or form support structures for plants or animals. For example, the nautilus shell, a naturally occurring object that results from the growth of a nautilus, forms in a very precise logarithmic spiral, meaning every compartment of the shell is larger than the preceding compartment by the same factor, regardless of its position in the shell. The veins of many leaves are also arranged in a fractal pattern, making it easy for nutrients to flow into and out of the leaf. Romanesco broccoli, perhaps one of the most well-known fractal patterns in nature, grows in branches or buds. Each large bud has several smaller buds, which themselves have smaller buds, and so on. While these natural fractals are not infinite like their mathematical counterparts, their self-similarity is well modeled by fractals. Many non-biological processes or objects also demonstrate repeating self-similar fractal features. Snowflakes have a fractal structure due to the organization of water molecules within them, which is often reflected in the 6 branches of snowflakes or the frost seen on windows. Many metals have branching microstructural features close in appearance to trees, which are known as dendrites, resulting from specific crystallization parameters. Flowing water often spreads out in fractal patterns, such as the alluvial fans of rivers that terminate near mountains. The flow of water, wind, or other sources of erosion can form fractal patterns in features such as coastlines and mountains, as the driving forces of change often act more strongly on areas which have already been acted upon in a recursive loop. On a larger scale, solar systems and galaxies have been observed to organize in self-similar patterns, something that defies many previous theories. At the most basic level, fractals occur in nature because of the repetition of a process or force acting on something, such as the erosion of land by water or the growth of leaves on a fern plant. The persistent action of water on a surface can introduce cracks, which expand and open up more surface area for new cracks to form, thus creating self-similar features. The force of evolution drives living things to be as simple as possible while still being able to survive. The shortening of an organism's genome can be beneficial, as it would require less resources to reproduce.
Oh,
Uh-oh.
he's my miracle child.
Commercial.
So how does your miracle child get?
In this respect, fractals offer a marvelous method for living structures to simplify, as it is easier to genetically store the self-similar information of a fractal than the details for every small structure, as seen in the fractal patterns of fern leaves. For some natural fractals, it is still unclear why they organize into self-similar patterns, although the driving principle is likely related. Humans have noticed the patterns in natural objects for thousands of years, and many human creations have been inspired by fractal patterns. For example, the organizations of towns and villages historically have often followed fractal distributions. The logarithmic spiral is a prevalent feature of much of Renaissance art. Humans seemingly followed the self-similar patterns seen in nature subconsciously, and modern research has shown that humans prefer art designs that show fractal geometry over those that don't. Many scientists investigated the patterns of natural structures, such as the nautilus shell, ice crystals, or the veins in the human body. Human models of these patterns were simple, such as the logarithmic function or repeating geometrical features, but advanced several areas of mathematics, science, and technology. Many scientists continued to investigate the mathematics of recursion and self-similarity, but the study of fractals was reinvigorated with the advent of computing in the late 1900s. In the late 1970s, Polish-French mathematician Benoit Mandelbrot began studying fractals, specifically the Julia sets created by French mathematician Gaston Julia 6 decades prior. At the time, Mandelbrot was among the research staff at IBM and used the computers available to him to plot the Julia sets, specifically highlighting the points in the set that did not go to infinity but stayed between certain bounds, now known as the Mandelbrot set. Building on the work of George Cantor, Gaston Julia, Felix Hausdorff, and Louis Fry Richardson, Benoit Mandelbrot wrote many papers and books on a new field of study, fractals, a name he derived from the Latin word for fragmented. Mandelbrot demonstrated the application of fractals to natural phenomena such as coastlines, as well as unnatural phenomena such as the stock market. In addition to applications in mathematics, fractals have been used to model or design novel systems in fields such as medicine, computer and electrical engineering, biology, chemistry, environmental science, cosmology, and many more. Unlike the familiar 1, 2, and 3-dimensional figures, fractals do not have integer topological dimensions, and instead can have non-integer or Hausdorff dimensions, which allow for closer approximation of natural features. The simplicity and high surface area of fractals make them ideal models for simplifying and improving existing or theoretical designs. Fractals have found ingenious applications in biology and medicine due to the multitude of natural systems that follow recursive patterns in at least one respect. Some bacteria's growth has been well approximated by fractal models, and these models can also help predict the locations of bacterial colonies. The growth of blood vessels in the human body follows fractal division, a phenomenon that can be disturbed in cancerous tissue. Fractal analysis of blood vessel growth in tumor tissue can offer new insights into cancer. The organization of neurons follows fractal patterns, a feature that may help understand how the human brain functions. Fractal distributions have been used to determine the distribution of plants in managed forests, analyze the distributions of alveoli and lungs, and even research the genetic systems of cells. Fractal models have been successfully applied to physical processes such as turbulent flow and aggregation of molecules due to the similarity of the physical laws that govern how such things occur. Fluid dynamics, as chaotic and potentially recursive phenomena, has been reproduced numerically by fractal approximations, which has helped model such things as fluid flow around airplanes and ships, the kinetics of mixing in industrial processes, and many other engineering problems. Some porous structures are fractal to a degree, and fractal models have been used to model porous media for petroleum engineering. The randomness seen in fractals can be similar to the Brownian motion of molecules in liquid or gas, and semi-fractal models have been used for approximation of diffusion, aggregation, and electrodeposition of molecules in materials engineering. Due to the high surface area to volume ratio of fractal patterns, designs that incorporate fractals have been implemented to minimize the mass or size of applications that require high surface areas, such as antenna or cooling units. This approach has shown great promise, achieving equal or higher specifications with significantly less material used. Using the principles of self-similarity at any scale, fractal patterns have been used in a new method of image compression, which offers clear resolution at any scale. The natural world has an abundance of chaotic processes that shape the world we live in, and these processes often create the self-similar things we see around us. Learning from these natural fractals has given us the ability to advance our knowledge of the physical world and to apply this knowledge to novel creations. In the future, the study of fractals will lead to greater inventions and may help answer our lingering questions about the universe.
Okay.
Thank you for watching.
Here, let me just show you this one in the background. So Julia said is a generic for the concept of these mathematical patterns that feed on themselves, and they call that iteration. So the one Mandelbrot came up with, which is the one we're looking at here, is z equals z squared plus c. And if you graph that and you give different colors in the graph, if you have the different colors in the graph represent different ways in which the lines on the graph is moving either towards infinity or towards zero, and give that different colors depending on how fast it's doing it, you end up with these really fancy patterns. And the most curious thing about them is this, what we're seeing here really is it's a graph of a mathematical formula represented with colors, and we're zooming into the graph to see more and more detail, sort of finer and finer divisions of the numbers. And what's so bizarre mathematically is that this process goes on for infinity, that you can keep going smaller and smaller and smaller, and you can do the reverse. You can go out and get bigger and bigger and bigger and bigger. Some parts of the graph end up just being totally white or totally black, which is sort of uninteresting. So you got to zoom in on the graph on the right place to make it interesting. But it has this infinite kind of process to it, where the math goes in on itself. Well, right. You remember last week, if we talk about a process that's iterative, that feeds on itself, philosophy already has a word for that, right? Dialectics. Because that, especially the negation of the negation that Hegel talked about, the thesis, antithesis, synthesis, right? That's a process that is represented in philosophy, in ideas, by this iterative formula that A yields not A yields some super A, which then produces a not super A, and so on and so on. And so there is in philosophy already this pre-existing system for thinking about reality in ways that move like this. Dialectics. Now, so interestingly, in the deep history of that thinking, it goes back to, the original formulations are in the 6th and 5th centuries BCE in China with the development of Taoism, and in Greece, especially with the thinking of Heraclitus. And both of those systems of thought are expressing this idea that reality is a process, and that process feeds on itself. And so if we can understand that process, then we can understand the world around us much better. So my point in bringing this all to you all is just to illustrate that dialectics as a philosophical approach then is noticing and actually in many ways helped feed the theoretical math that went into developing these ideas, because they're related ideas that what the reality that we're trying to understand, trying to relate to is a process. It is moving all the time. And this is the Mandelbrot set, and this kind of fractal geometry just represents math trying to figure out how to represent a reality that keeps changing on it. And so that's actually sort of the fundamental problem that in a sense we're trying to get past, at least on a philosophical level, is we're using tools which are didactic, and kind of analytic. They break up into little individual discrete pieces, like words do or mathematical formulas do, and that we're trying to use those tools of things that are broken up into discrete pieces to represent a reality which is actually interconnected, so not discrete, and a process is so constantly changing even as we're trying to describe it. And so you have to have this astoundingly complicated sort of math for mathematics to be able to do this kind of thing. So so that's sort of one big piece to notice about the importance of dialectical, and I'm going to add materialism to it here in a second. But the reason why dialectical materialism then can step in to offer a deep philosophy akin to the role that the divine plays is because it is a philosophy that is representing reality in this ultimately complicated way, that we want to fundamentally get at the weirdness of the fact that it's always changing. So dialectics and Mandelbrot. So I think these ideas in fractals, I think it's these are kind of important things that need to go together. So the other piece of that is going to be is the material piece. And so there I want to show you that theoretical physics, following the theoretical math, is also uncovering a reality that is process-like, so undergoing change, and also is interactive in the way because the math is finding the interactive. But we're wanting to combine all of that, the complicated mathematical description of how the process of the material is changing, and that's kind of going to be the ultimate goal in terms of relating to kind of a full fleshed out theory of what is this reality that we're looking at, what is the deep structure of our worldview. So in that, yeah, Bill, question. Oh, you're muted.
It seems as though the visuals of this and some of the science that comes out of it, I guess, relate to certain of your senses. But for instance, I don't want to preempt anything, but will you be getting into music, for instance, as a sonic, similarity in a way?
I won't, but
Very much a part of religion in a way, at least some religions, and or language too, and poetry. So I'll leave it at that. But I think music is certainly very much, has a lot of similarities, a lot of mathematics that are similar, and so on. And I'll leave it at that. So
yeah. So, and like they were saying, that humans have a preference for these kinds of patterns, and the argument, the kind of theological argument in there is, well, of course, that's because that's the reality that we were evolved into, and so we appreciate that complexity because it's interesting. If you have to, if it's just plain, it's going to be boring, but it needs to have complexity to be interesting. And so you bring in that complexity, and the reason, pointing out that these ideas go back to Taoists and ancient Greeks is that it's a very old insight that we need to think about the world in terms of process and change, not in terms of static realities. Now, see, the big problem that philosophy had is that idea is there in ancient Greece, right? But Plato, actually, it's Parmenides first. Parmenides comes along, and then Plato after him, and they both are they're both challenging this way of thinking in the same way by arguing that the change must not be real and important, and that what's real and important is actually something that doesn't change. And so you get these Platonic forms. So philosophy, Western philosophy, has been following that Platonic line and sort of thinking about arguing with Plato about that idea for 2,300 years now. But that's just the wrong line of thought, that what's real is not what's permanent and unchanging. What's real is what's changing. And so this is actually why Hegel really is so groundbreaking and kind of earth-shattering the way he is because he's brought back to Western philosophy the whole idea that we can think about the world as a process that's changing, and we don't have to focus on this idea about eternal features like forms as the fundamental basis of reality. So dialectics in Western thought offers up this really revolutionary way of thinking about the world that has all of these deep implications. And what I'm doing is just taking those deep implications into the realm of religion by arguing that, one, we can use part of it to help us understand religion as a phenomenon, but two, we can use the deep philosophy as a way of offering new material for religion to work with. Instead of having to focus on something divine and unchanging, we now can focus on the fascination of reality that's always moving. Yeah, Joanna.
Not everybody. It seems in the common vernacular, something that's unchanging is also valued. Like, I've been doing this for 25 years, or I've lived in the same town forever. I mean, there's an element of, value in doing the same thing over and over again.
Right. So I think, and I think that has two. So that's tracking that philosophical tradition on the one hand, but I think it's also human in the sense that things changing all the time is frustrating and difficult.
Oh, that's true.
So we have a kind of emotional attachment sometimes to things that are the same, just because it's just a little easier on us. It may not be as interesting, but it's just.
You're absolutely right. Yeah, I could see that.
Yeah. Okay. So next we want to talk a little bit about the how curiously weird physics has gotten on us too. So here, well, I don't know. I mean, the video does a pretty good job introducing it, but just important to know, string theory in physics is highly theoretical, very mathematical, and suffers from a technological problem in that the ideas they're coming up with, they don't know how to test them. They don't have the technology to actually test them. So as science, it's a little awkward because you're coming up with a theory you can't test. But as philosophy, it's way too mathematical to be thought it's philosophy, but it definitely operates somewhere kind of in between those two at the moment. And someday they may figure out ways of testing these things. But for the moment, this is sort of physics noticing, okay, if reality is going to be this weird dynamic thing that's always changing, how should we understand that? And this is all implications that have followed from the work of people like Heisenberg and Einstein 100 years ago.
You have probably heard of string theory, an attractive development in theoretical physics, which has run wild through the scientific community and media alike. It has seen so much attention due to its incredible answers to deep questions of fundamental physics, to the extent that some consider it a candidate for a theory of everything. String theory itself is not exactly a theory, but more a type of theory called a theoretical framework, through which there are multiple different versions of the same base principle. String theory's base principle is that all the points of particle physics, like leptons or quarks, are replaced by one-dimensional strings, which are on the scale of the Planck length, and are either open or closed.
Okay, here I thought I should try and he doesn't define it. Planck length. This is kind of an important concept in physics here. Planck, that was his first name. Anyway, important physicist, early 20th century, came up with this idea about how to that there was at the bottom sort of scale of possible measurements, there is a bottom at which reality sort of a basement that things hit where they can't possibly get smaller. And the number that he comes up with is like 10 to the minus, I think it's 34th or something, or 35th. It's in between these is what they're trying to get us to. But so they're talking about reality in the form of little tiny things. So, right, this is the atomic nucleus is 10 to the minus 15th meters, and we're talking about 10 to the minus 35th kind of scale. So it's, so you think about how big an atom is, and this is something that's fractions of a fraction of a fraction of the size of an atom is what they're talking about when they talk about something that's a Planck length. So the idea is in string theory, that everything everything we call reality is reducible to these little strings and little that vibrate, and depending on the details of the string and the vibration, they will eventually form different subatomic particles and then different atomic particles, and so the world that we know. And so, okay, just wanted to get that cleared up here.
These strings vibrate, and the way they vibrate determines which particle they look like at a larger scale. But for the maths to support various string theories, we need more dimensions. At the moment, we are very happy with our 3 spatial and 1 time dimension, but string theorists imagine that there could be many more. Bosonic string theory, for instance, theorizes that there are 27, yes, 27 different dimensions to our universe. The reason that we don't notice these extra dimensions is because they're curled up incredibly small. Imagine you have a pole on which a tiny object can move. Close up, you can easily see how the object can move not only up and down the pole, but around the circumference as well. And the object itself would only be able to comprehend these 2 dimensions. However, if you step back far enough, you will only be able to notice 1 dimension of movement, up and down. This is the essence of extra-dimensional space, or hyperspace. String theories allow quantum gravity to be explained, something that very few quantum theories have been able to do. Gravity, as understood by Einstein's general theory of relativity, often has serious disagreements with quantum physics. One main reason for this is that gravity, describing the geometry of space-time itself, requires precise measurements of distance, and at the quantum level, these properties cannot be measured precisely enough due to the Heisenberg uncertainty principle. The brilliance of string theory is that it introduces gravitons, particles that mediate gravity, allowing gravitational interactions to be explained in quantum physics. This was what caused some to name string theory a potential theory of everything, despite others criticizing it for its unfalsifiability. Well, what makes a theory of everything? A theory of everything, in the most basic sense, is a theory that encompasses, well, everything of modern physics. This seems like a great deal of work, but thankfully a lot of it has already been done. We in fact have a single model, humbly called the Standard Model, that describes almost all of the known universe, excluding one or two final stepping stones. The biggest of these final pieces is gravity, and a clear signpost that you have a theory of everything on your hands is if it connects gravity to the Standard Model. As we know, general relativity, Einstein's theory of gravity, really dislikes quantum theories. But there is another very promising scientific principle called supersymmetry that could help us combine gravity and quantum physics. Supersymmetry is the principle of treating forces and matter equally, and predicts cousin particles for every elementary particle we've observed, the superpartners. These superpartners are of the opposite class to their regular versions. For instance, electrons, supersymmetric partners of the electron, are bosons, where electrons are fermions. A supersymmetric theory would have its force equations identical.
Now we're hearing something bleed through again on someone.
Complete your assessment. So please give me a call again at 206-523-7315. Thank you, Carol. Bye-bye.
Okay, might have been Carol. Okay, anyway, so while I'm paused, something else that has opposites. That's the first thing to notice, right? That in order to have the force equations and matter equations work, what they've come up with is that every particle has to have an opposite. Well, dialectics, everything has its opposite.
Of matter equations. And for this reason, many physicists are attracted to the way supersymmetry relates force to matter, bosons to fermions, making the Standard Model more elegant. Physicists already appreciate the symmetry in particle physics between the 6 quarks and antiquarks, and between the 6 leptons and antileptons, and can see the mathematical significance of this symmetry. On the other hand, many criticize supersymmetry on the grounds that no superpartner particles have been observed. And to test the principle, it would take a gargantuan-sized particle accelerator, capable of collisions up to 7 million times more energetic than the LHCs. Nonetheless, supersymmetry, when combined with general relativity, results in very elegant and satisfactory solutions. And this is called supergravity. Supersymmetry can also be applied to string theory, and this gave rise to 5 superstring theories, each with 10 total dimensions. These superstring theories individually explain a number of questions in quantum physics, and do so extremely well. However, these superstring theories were found to be perturbative, with no single one seeming to be a theory of everything, and it looked like string theory had failed to reveal the nature of our universe. There was until an American physicist named Edward Whitton noticed that the 5 string theories could be mapped to one another by certain conditions, known as dualities. Then, the string theory conference at the University of Southern California in 1995, he suggested that instead of these string theories being distinct theories, they could in fact be cornerstones of a more fundamental theory called M-theory. This started a huge amount of work, which became known as the second superstring revolution. M-theory could be defined as a proposal for a unified quantum theory of the fundamental constituents and forces of nature, which contains within it the 5 superstring theories and supergravity. It has since been considered the best candidate we have for a theory of everything by the likes of Stephen Hawking and Michio Kaku. But the M in M-theory might as well stand for mystery or miracle, because no one really knows very much about M-theory at all, even its name. M-theory could be a single theory or a network of different theories. In either case, we are already aware of some of its base principles. Firstly, M-theory is 11-dimensional, and it contains not just one-dimensional strings, but other fundamental objects with a range of different dimensions, called p-branes, where p runs from 0 to 9. This includes 0-dimensional points, membranes, which are 2-dimensional sheets, 3-dimensional blobs, 4-dimensional hyperblobs, and so forth up to 9 branes, which are pretty difficult to imagine. The 11 dimensions of M-theory contain our familiar 3 macro dimensions and time dimension, but what about the remaining 7 tiny dimensions? These extra dimensions must be either curled up or at right angles somehow, otherwise they would cease to be tiny dimensions. And the maths of M-theory restricts the number of ways the internal space can be shaped as such. We know that the shape of internal space directly affects the values of physical constants, such as the charge of the proton, and the way elementary particles interact. In this way, the shape of internal space
There's a
determines
point where he's getting a little more technical than I need him to get for my purposes. So what I'm wanting you to sort of appreciate in putting this all together is that when you encounter something like a deep philosophy like dialectical materialism in that form of Marxism, that it's as a worldview, as a metaphysics that has a view of ultimate reality, I would point at fractal theories in math and this kind of string theory, the M theory, supersymmetry, especially in physics, and notice that that's the kind of thing that if Marx and Hegel are right, that's what you would expect to find. And so I think something like that. Now the problem is I'm not competent to understand the math or the physics that these people are talking about. So I think I have a little footnote even in the chapter where I'm quoting a physicist who was trying to explain something to me about a theory that Lenin had about an infinity of matter. And, it's just, I am just not competent to follow those kinds of arguments. But just experiencing them, I think, is itself a kind of spiritual experience in that the kind of weird complexity of the theory is a kind of thing that you can bathe in, and if you try to follow me through that through that kind of metaphorical language, that it sort of comes at you and washes over you, and you try to absorb some of it, and a little of it might get in, but that wave just goes. For me, there's something akin to a kind of mystical experience that can be had by trying to appreciate just how bizarre the things are these people are talking about. And I guess that's the kind of idea that I want to get at. All right. Now, so from there, what I want to do is take that back into dialectical materialism and sort of have you sort of see, if not just experience, kind of the feeling of these things connecting to each other. And I have two versions to show you, one that's short and one that's a little longer, and I think that they help because the short one goes through things real quick, and then the longer one will kind of explain a little bit more detail. So, and I think they're all British for some reason. Oh no, this guy's American.
The incessant change in the world. The dialectical world outlook sees the incessant change in the world as the first principle of reality. For the dialectician, the world is in a constant flux. What I want to do today is give you what, for Engels, inspired by Hegel's logic, were the 3 central laws of the dialectic. First, we have the law of the transformation of quantity into quality and vice versa. This law states that a quantitative accumulation of one thing eventually leads to a qualitative leap into something else. If I have a cup of water and I continuously drop a degree, at one point when I go from 33 degrees Fahrenheit to 32, we have a qualitative leap. And now the water goes from being in a state of liquid to being in a state of solid. It turns into ice. Secondly, we have the law of the interpenetration and unity of opposites. This law postulates that everything is composed of internal opposing forces. What this law does is help us see the internal dynamic that is responsible for the quantitative and qualitative forms of change we previously examined. Lastly, we have the negation of the negation. This law deals with the progressive development of qualitative forms of change. To show you this law, I'm going to bring in my friend, Mr. Red Bell Pepper. If I take this bell pepper's seed and I plant it, what's going to happen is that under the right conditions, the seed will negate itself into a plant. And if the conditions continue to be right, that plant will again negate itself, the double negation, the negation of the negation, into a plant that carries with it a few bell peppers. Isn't it beautiful? From a single bell pepper seed, we have received a plant with a few bell peppers. This seed has undergone its natural process of the negation of the negation, and through two qualitative changes, it has produced more than what it previously was. Thank you for watching my prop-filled introduction to the laws of the dialectic. If you want to learn more, check out my 17-minute video on the topic, or check out the few essays that I'm going to tie to the description down below. Carlos Brito, Midwestern Mark, signing out.
So the idea is that the philosophy is noticing the thing that the math and the science is noticing, but it's dealing with reality in a more complicated way, because it's sort of it's the natural world as a totality that we live in. We don't live in it in the little pieces that individual scientists are investigating. And so in that totality of sort of how the natural world is acting around us, we see the pattern, or see patterns, see that there are patterns. And actually here, one kind of side note in psychology, there's one old way of talking about intelligence, especially when you're talking about trying to measure intelligence between different kinds of animals, that what you're really measuring is pattern recognition. That the more intelligent a creature is, the more or even a person really, the more complicated the patterns that they will recognize around them. And so as a philosophy, dialectics is saying, okay, reality is change. That's an important pattern. How does it change? And that's where the dialectics it also gets complicated, the same way the math and the physics are going to get complicated when you ask that kind of question. How does it change? And on the physics side, what I was pointing to is one version of that change. So what Hegel really comes up with is the change has three different aspects to it. So mutual interpenetration of opposites, and the other video is going to explain all these in a little more detail. So mutual interpenetration of opposites, that is, the things that we think of as opposites are actually deeply connected to each other and can't really exist without each other. So opposites is our human experience of them. They're much more integratedly connected. And we'll have examples later here, but mutual interpenetration of opposites, the change of quantity to quality, so that you can change a quantity of things and eventually you produce a qualitative change. That was the ice example. And then the negation of the negation, which is Hegel's language, or thesis, antithesis, synthesis in kind of the more modern interpretation of Hegel. So that all of that change, then philosophy is noticing has its own complexity to it, because we can talk about the change in these three different ways. Math and physics have to catch up with that. So the philosophy can kind of come first and note and figure out the basic parameters of the problems then that it hands off to the sciences. That's kind of the history of how philosophy has worked. So, and the same thing kind of here, although it doesn't always, it's not following in a time linear fashion, because ideas move around. And some get ascendant, like permanent things count, some ideas have this ascendancy and take over for a while. So So dialectics suffers from having been a extreme minority theory for so long. But anyway, so I think that's that change then, that's going to be the vital piece. Okay, so we'll go to the more complicated version of that. This is my English Marxist guy. Oh, let's see, I didn't need that intro, right? Okay.
Dialectics and materialism. Understanding of this important topic. Now, in order to develop a well-rounded understanding of dialectical materialism, we need to consider both of its aspects in detail, dialectics and materialism. But first of all, we need to clarify a couple of points up front. When we talk about materialism, we're using the philosophical understanding of the term rather than the popular concept of being materialistic. We're not talking about being overly concerned with worldly possessions, being obsessed with acquiring consumer goods or anything like that. The philosophical materialism that we'll be talking about today is in contrast to philosophical idealism, which is not to be confused with the popular usage of the term idealist to describe a person who's guided more by lofty, unrealistic ideals rather than by practical, realistic, grounded considerations. So that's what we're not talking about. Now let's get into what we are talking about: dialectics, materialism, and their combination into dialectical materialism. Welcome to Socialism 101, a series designed to help educate people with no prior knowledge on the basics of socialism and communism from an explicitly Marxist-Leninist and Marxist-Leninist-Maoist perspective, with short and hopefully easily digestible videos. If this sounds interesting to you, then go ahead and subscribe and turn on the notification bell below. Now, dialectics as a concept has been around for thousands of years, and we can trace its roots back to both ancient Eastern and ancient Western philosophy. We can look to the works of Plato to see demonstrations of an early idealist dialectical method. These are dialogues between two characters who argue back and forth with one another, refining their arguments in the process through exposing flaws in each other's positions, and together developing the correct conclusion. The first person will initially present an argument, the thesis. The other person will then present a counter-argument, the antithesis. And through argument, a more refined position is reached between them, the synthesis. But that's not the end of it. Now this synthesis becomes the new thesis. And in opposition to this new thesis, we see a new antithesis emerge. And from this new thesis and antithesis, we arrive at another synthesis, and so on and so forth. And this triad of thesis, antithesis, synthesis is often the way in which we're taught to understand later iterations of dialectics, most notably the idealist dialectics of George Wilhelm Friedrich Hegel. However, it's important to state clearly that Hegel himself never formulated it this way, and that this simplified formulation can cause problems in trying to correctly understand dialectics. Importantly, rather than seeing the thesis emerging and existing by itself for some time, only to be challenged by the antithesis at an indeterminate later stage, the thesis and antithesis, the two contradictory aspects, emerge simultaneously. For a less abstract and more concrete example of this, there can be no exploiter without the exploited, no bourgeoisie without a proletariat. Their existence depends on each other, and so both emerge simultaneously in unity and contradiction with one another, a unity of opposites. Now, you'll notice that by introducing the dialectical relationship between the proletariat and the bourgeoisie, we've shifted gears from focusing on the contradiction between simple conversational ideas, the realm of philosophical idealism, and have instead moved to discussing class contradictions, the realm of philosophical materialism. Unlike Hegelian dialectics, which rely on idealism, Marxist dialectics are materialists. But what does this mean?
Why should you use Miro? When you draw on a whiteboard, no one sees it. With Miro, you plan together in real time.
Philosophical idealism posits that existence is inseparable from human perception, that reality primarily stems from the mind perceptually or from ideas of some kind. This is exemplified in the statement, "I think, therefore I am," wherein thought precedes and affirms reality. The beginning of existence here is subjective thought. Extreme versions of philosophical idealism can be seen in solipsism, which holds that a person can only be certain that their own mind exists, and that everything else outside of that is potentially just an illusion. Philosophical materialism flips idealism on its head, becoming "I am, therefore I think," wherein objective existence precedes subjective perception. Rather than assuming that all existence begins with the ideal, with subjective thoughts, with consciousness, the products of the mind, Philosophical or ontological materialists accept that there is existence beyond and before our mere perception, that matter objectively exists independently of whether or not we subjectively perceive it. In stark contrast to idealist notions, Marx posits that it is not the consciousness of men that determines their being, but, on the contrary, their social being that determines their consciousness. Marx believed that this idea of a mind that somehow exists separately to our physical bodies is incorrect. It is impossible to separate thought from matter that thinks. This matter is the substratum of all changes going on in the world. Thought then comes from matter, the brain being the material organ of thought. Lenin summarized it when he stated that materialism in general recognizes objectively real being, matter, as independent of consciousness, sensation, experience. Consciousness is only the reflection of being, at best an approximately true, adequate, perfectly exact reflection of it. In other words, materialism holds that objective material reality exists, whether or not we subjectively perceive it, and that matter precedes thought. Therefore, materialists begin our analyses by studying matter. Now, this battle between idealism and materialism has been a long-standing debate in philosophy. However, modern science has long since come to embrace materialism as its starting point for research. But where the popular materialism of scientific discourse often falls into the trap of being a materialism that finds itself static, rigidly fixed in one place, Marxist materialism is anything but static. Rather, Marxists view all matter as interconnected and constantly in motion, constantly changing. Darwin's theory of evolution illustrates this interconnectedness of everything in the material world and the process of constant change and motion. Everything that currently exists only does so as the result of processes that have been ongoing for billions of years, processes of dialectical development between opposing or contradictory forces. It's precisely the study of dialectics which allows us to move beyond metaphysical rigidity and understand the perpetual motion of the material world. Lenin reminds us that dialectics in the proper sense is the study of contradiction in the very essence of objects. Objects here meaning literally all phenomena. Let's take a deeper look now at contradiction through the fundamental laws of dialectics.
Dialectics. How can we better understand it and apply it to the world around us, and especially in our organizing efforts? Well, one of the fine gentlemen behind me laid out 3 fundamental laws to help us understand dialectics. The first law is the unity and struggle of opposites. The second law is the transformation from quantity into quality. And the third law is the negation of the negation. Let's break these laws down. The law of the unity and struggle of opposites holds that the unity of opposites exists in all objects and processes from beginning to end. Vladimir Lenin once said, "The splitting of a single whole in the cognition of its contradictory parts is the essence of dialectics." And Mao Zedong once said, "The law of contradiction in things, that is, the law of the unity of opposites, is the basic law of materialist dialectics." Within every object, 2 contradictory aspects form the entire object. These 2 aspects both unite and struggle, pushing that object forward, placing it in constant motion. This is also known as the law of contradiction. Lenin said it best: in mathematics, plus and minus, differential and integral. In mechanics, action and reaction. In physics, positive and negative electricity. In chemistry, the combination and dissociation of atoms. In social science, the class struggle. 1 divides into 2 is another way of identifying the contradictions within an object or process. In this case, mathematics is divided into plus and minus, physics into positive and negative electricity, so on and so forth. As dialecticians, we must find the 2 contradictory aspects of that object in order to understand it concretely. This is the law of unity and struggle of opposites. The law of the transformation of quantity into quality. This law explains that gradual quantitative changes give rise to revolutionary qualitative changes. Basically, Quantity is gradual change. Quality is revolutionary change. This law takes into account how all things and processes go from being one thing or process to transforming into another thing or process. The essence of a thing gradually changes through increases and decreases, but after a certain level of gradual change, a qualitative leap occurs which fundamentally changes that thing or process. With this law, we must understand that a fundamental change that occurs within an object doesn't just occur with gradual changes, but a qualitative leap must occur for actual change to occur. For example, when we heat water up until it boils, the temperature gradually changes until it transforms from a liquid to a gas, representing a qualitative change. Or when we freeze water until it transforms into a solid state known as ice. Examples like these are found all over the universe, including human society and human thought. In the Marxist sense, when we apply this law to society, the qualitative change is revolution. This is the second law of the transformation of quantity into quality.
This is History of the World Part 2. Mel Brooks, you ever heard of him? Wait, Mel Brooks is a part of this. You want Jesus to be...
The law of the negation of the negation. This is sometimes referred to as negation and affirmation. And the simplest way to explain this law is when the new supersedes the old. When the old state of an object reaches its limit before a qualitative change occurs, this is the first negation. After surpassing this limit, the object transforms into a new state, which is the second negation. Therefore, we have a negation of the negation. The negation, or the limit, is negated or superseded by something new. Karl Marx described an example of this law. The capitalist mode of appropriation, the result of the capitalist mode of production, produces capitalist private property. This is the first negation of individual property as founded on the labor of the proprietor. But capitalist production begets, with the inexorability of a law of nature, its own negation. It is the negation of the negation. This does not re-establish private property for the producer, but it gives him individual property based on the acquisitions of the capitalist era, meaning on cooperation and the possession in common of the land and the means of production. Negation, in the Marxist sense, does not mean completely wiping out the existence of something. In the process of an object transforming from one state to another, old remnants of the old state still remain in the new state. When feudalism became dominant after slavery, slavery still remained. When capitalism became dominant after feudalism, old remnants of feudalism still remained. Even when socialism becomes dominant after capitalism, slavery, feudalism, and capitalism still have remnants which remain and must be overcome in order to reach communism on a global level. A negation of the negation means a transformation from the old state into a new state of an object, when the new supersedes the old, but in a way which has continuity with the past, but also ruptures from it. This is what Marxists mean when we say progress does not travel in a straight line, but in spirals. Lenin described it as, human knowledge is not or does not follow a straight line, but a curve, which endlessly approximates a series of circles, a spiral. To sum up, life, society, and ideas are in a continual process of gradual changes, which can build up into revolutionary qualitative changes due to the contradictions within a process. And this is all pushed forward by the unity of opposites within that process. And there we have the three laws of dialectics, which form the basis of the philosophy of Marxism.
Today we've taken a look at the development of both dialectics and materialism. We've traced dialectics all the way back to Plato.
Okay. All right. So, what did I want to do here? No, I want to do this. I want to do that. Okay. So the way that actually, I guess it was Lenin who put it this way, that dialectics manifests in nature, society, and thought. And so as a philosophy that's occupying this place of worldview, it's covering all aspects of human experience. So dialectics then applies to the natural world, and that's why I wanted to show you the stuff about the physics and the math. So that's kind of, and that's in a sense, like I was saying, so it's like the deep philosophy, because if you're not a mathematician, you just can't relate to it except as a mystical thing. So in nature and in society, and so that's where you get then historical materialism as Marx's philosophy of history is actually just dialectical materialism applied just to the question of society. That's historical materialism. And then thought. And so then that's the idea then in logic, in like Hegel's dialectical logic, or just sort of more generally in this sort of philosophy, so that it shows up in the philosophy, in human thinking, because we look at the world and then use these ideas, in particular, those three forms of the dialectic in particular, use those ideas to help us navigate all of these different patterns, to find the patterns in the world and try to navigate them. So to bring it all back around, then, that it's what I'm suggesting is that where ordinary theology has invoked a mystery it calls God, an atheology, which is the word I play with at the end of the conclusion there, a theology that has embraced an atheism can substitute that mystery called God with the mystery called dialectics. But mystery in the sense that it's a complex pattern that we never really probably fully can understand. Now that works on a couple of levels, right? So at one level, theology wants to offer a worldview that is sort of coherent, in a sense that here's how the world is, this is how the world works, this is what people are like, this is how people should behave. So we get a worldview out of that in a sense. The details need to get filled out, especially if you get to kind of the human senses. Well, how should humans live? How are you going to develop the ethics that's involved with all of that? That's a complex task. But all of that married to this kind of deep philosophy then can be occupy this theological place, especially if one then is trying to marry these ideas into an existing tradition. It also would work if you were trying to create a new tradition, like to create a whole new religion. But remember, the religion is identifiably religion when you have the worldview and you have the ritual system that goes with it. So ritual systems are relatively arbitrary historical facts. They're the things that human beings in a particular culture with its way of living, the material conditions that it has, comes up with, right? So Hebrews come up with the idea you need to appreciate God by sending smoke up. A lot of African cultures came up with the idea you appreciate the gods by spilling the grain or milk on the ground. Okay, so different experiences of the world coming from different places, and so they come up with these different patterns of behavior that eventually get ritualized and worked over time into systems. So it's fairly difficult to come up with a really new religion, because the ritual systems tend to evolve kind of naturally on their own. So what's occurred to me over time is the more natural approach then is to bring these ideas into an existing tradition rather than trying to create a new tradition. So because there's definitely there's a competition going on at the realm of theological ideas, whose theological ideas are going to have the most currency. And then the issue is, okay, where's the turf for that battle going to be? Well, if it's a new religion, that's a really big fight. If it's part of an existing one, it's at least a known fight. We kind of, well, you kind of know what you're getting into and having it, I guess. So I've at different times in the last 2 decades, I've had different thoughts about how to approach that question. When I was writing the dissertation, I think I was leaning more towards, well, maybe a new kind of approach would be an easier way of getting these ideas to people and kind of into the world. Over time, I think I've come to the other position, which is where I am now, that's actually going to be really, really difficult, and it's going to be much easier to bring those ideas into conversation with an existing tradition instead. So that's actually where I'm going with my next book is I'm Jewish, so I'll take that into a conversation with the Jewish tradition, as opposed to try to create a new tradition. So that's the idea, basically. Making any sense yet? Some of it's complicated, so I do feel like I say things over and over again a few times, hoping that eventually I'll hit something that makes some sense to you. But Helen, I think you have your muted here, so you.
Yeah, I am muted. It really also comes down to a connection with the self.
Mm-hmm.
And we seem to escape that connection with the self into the other selves. We walk away from what we are. And maybe that has to do with my age. I'm 86. Pretty soon I'm going to die. So what do I think about the self? How did I grow? What did I do with it? And how will I look at myself? Because eventually we all die alone. And that to me is extremely important. And all this collective thinking is wonderful. And we need it, but ultimately it's the I that counts. And that may be a very egoistic thing to think, but to me that is very necessary, because that I will have, like that pepper and the seeds, will have been passed on to some of me around me, and grow into a being. So it's symbolic. That pepper is symbolic to me. It was very good to see. So all in all, I find this fascinating, and it's far above my head, but it's actually rather simple. It comes to me. I have to take the responsibility of my life, my thinking, my doing. And that you cannot just pass that on to a religion, to a society, to anything. It's you.
Yeah, and I think that's why I invoke people like Camus when I talk about meaning. Because I agree with that way of thinking. The dialectical piece of it would be to say that that self and the society are one of those opposites.
Mm-hmm.
You actually have to get a sense of both of them, but and they're mutually interpenetrating opposites, but both very important in their own ways. And I think, and so understanding how they relate is also part of that importance.
So then the dialectic is within the self.
Well, I would say, you could look at it in a couple different ways depending on which one but in terms of interpenetration of opposites, I would call attention to self and society as
okay.
That I experience myself both as a member of the society and then as an individual. And they're both important, and they're both me. And so we're just saying at your stage in life, you're noticing the self more.
Yes.
That's fitting in the context of your life right now. And so that makes a lot of sense. And in other phases, you might have worried more about the self in community.
Yeah, but we also we have, of course, a string of memories, right? Mm-hmm. At the end of your life, your memories, your experiences, what you made of your life, what you are, what you leave behind in the thoughts of others.
Mm-hmm.
And that's very, very important to me anyway. It
Right,
is.
that's the community side. Yeah.
Yeah. And that is our responsibility. And, you know, I know that religion is important to a lot of people, but you really give away your creative self to something outside of yourself that you don't know is God. That what you know is what lives within you. I have the dialectics within me. I argue with it.
Yeah.
But if I become a slave to someone else's imagination, and that's something.
Then that's
you
bad.
lose you lose your creative self.
Yeah.
So my philosophy towards the ending of my life, I'm still arguing. I'm still having that dialectic within the self. And I hope that, you know, we all die alone, that I think, well, you did your best. You didn't do all good, but you did your best.
Yeah. Yeah, there you go. There you go. I know.
I just wanted to say, generally speaking, this is hopefully will be a quick comment about classes that I've taken from you, Richard. Having that math and physics part was so good, because string theory is kind of something that they just made up. And so I feel like I used to think the same thing about religion. You know, it's something just people just made up. And then I realized they did it in science too. And you have sort of broadened my attitude. I am no longer that opposite. I mean, I'm not so extreme on both ends, and I appreciate that.
Thank you. I think that kind of mirrors my own process since my master's.
No, really, I'm watching that string theory stuff and thinking, they made that up. They just made that up. That doesn't. Anyway.
Well, it's creative.
Yeah.
It's creative.
Yeah, and you measure it by internal consistency, which is, you know, how a lot of theology is measured.
Well, isn't, in a way, both theology and science really are attempting to solve an issue? I mean, it's in pursuit of
theory,
discovery. Of discovering something. And I forgot, was it in another class? I don't remember, but I even got an appreciation of astrology, because they said that in ancient times, because the earth was ever changing, there was no stability and storms and all that, that at least the stars, they could predict the stars with extreme accuracy, and this made them feel good. And I'm like, oh, that makes so much sense. So, you know, even astrology was an attempt to find some stability in a very chaotic world that they lived in at the time.
Very complicated patterns.
Yeah. But they were predictable in ancient times. The constellations were.
Yeah. I think that makes a lot of sense. The stars were a constant in a world of chaos. Yeah, makes sense.
Well, I just love this class too. I can't say enough.
Oh, well, thank you. As I said, I think in an email a couple weeks ago, I'm bereft of ideas. So about what to do.
And like me, Nina, you know, my worldview has shifted.
Well, that's, I mean, in the end, that's like kind of that's really flattering. I mean, that's the best teacher can hope for, is at least that the students will at least follow that they got excited and good, they develop their thinking, and the students can follow that to some degree. So that's really wonderful that you feel like you're following that. I really appreciate that. It's great fun for me. I definitely enjoy the teaching part. So I appreciate that's, you know, see the mutual opposites thing. I can't be a teacher without the students. So.
No, but you also have to trust yourself, right? You need to trust yourself.
Oh yeah.
That is necessity.
I have to add your final two sentences really struck me in your paper, that at the same time, it was humble and aspirational. Your
Oh,
last two sentences.
yeah.
I don't know, they just really resonated. I mean, it's so humble to say because I felt like it, you know. And then you want to change the world.
Yeah.
Begin with yourself.
Well, you know, we all got to try.
Well, that was good.
In our own way, right? In our own way.
Yeah.
All right. Well, thank you all. We've reached the end of class.
Well,
Thank you all
thank
very
you.
much. It's been a wonderful
Thank
experience. Great
Thank you.
new adventure for me trying to teach my own work. It's very interesting.
Yeah.
So I'll get this recording out a little later for people in case they want to see it again. And
you still
send some
want
little ideas.
emails? Oh, you still want emails on ideas for
Yeah,
you to
yeah. If
teach?
you have any suggestions or things you think you'd like to take, you think would be up my alley, let me know. I'm working on what to do next, and it takes a little time because I want to, you know, do the research first to get ready. So it takes some time. But yeah, let me know. Let me know. Thanks a lot. Yeah, hopefully I'll see
Thank you.
Thank you.
Thank you.
Bye.
Take care.
Appreciate it.